Today, we are going to see an interesting and important topic, that is crystal field theory. As we are seeing theory of coordination complex compound, Werner's theory says coordination complex compound having two valency, that is primary valency, secondary valency. Primary valencies are ionizable, secondary valencies are non-ionizable. So we have gone through that video. The second theory, it is VBT theory, valency bond theory, that what it has mentioned, metal and a ligand are purely covalent, it has mentioned, and we have gone through those sums also, how to find out all those ideas we have gone through. Now we are going to see the crystal field theory. You know who brought this crystal field theory? Bethy and V. Blake brought this theory. Okay, what he has mentioned about this in this theory means metals and ligands are purely ionic. How come it is ionic? Ligands and metals are having electrostatic attraction between these two complex compounds. Now the metal ion connected with the negative ligands, that is ion-ion interaction. Now for example, this is a metal ion which is connected with Cl minus, Br minus, I minus, such kind of negative ions. Such kind of negative ions, if it is connected, we can say it is ion-ion interaction. Ion-ion interaction. The same way, metal ion connected with neutral molecules H2O, NH3, CO. Okay, so these kind of ligands, this is neutral molecules. So such kind of molecules which is connected with the metal ion, this is ion dipole interaction. Okay, now as we are talking about metal and the ligand, we have to consider that metal ion of that orbital's conception. Okay, orbital conception means a d orbital, we have to notice. Now as we are seeing that d orbital, actually all the 5 d orbitals are having the same energy. You know the shapes of the orbital. Okay, now we are going to consider the shapes of the orbital, how it is occupying. Now, in the case of metal ion, 5d orbitals are having same energy. Those orbitals are called degenerate orbitals. So, degenerate orbitals are nothing. It is having a same energy. So, what are those 5d orbitals? Let us go and identify 5d orbitals. So, what are the 5d orbitals? dxy, dyz, dzx, dx square minus y square, and dz square. Okay, now let us go and identify in the axis wise. So dxy, how it will be? Now this is x and this is y. So how it will be here, like this, the orbital shape on the axis like this. So this is dxy, and the same way here dyz, yz like this, and this is zx, zx. So this also the same, but you see where what is there in this axis and that axis. So this is dyz, and this is dzx. Here dx square minus y square. So this is y and this is x. Okay, so this will be along the axis like this, dx square minus y square, and dz square, here z and here x. Here z square only, no, so the same way here only one. So like this it will be. So this is what it is, dz square. Of course, this will be minus z, this will be minus h. So, like, you know very well. Okay, now these are the 5d orbitals shape. Now, here I said same energy. In case of metal ion, all the 5 orbitals are same energy. Those orbitals are called degenerate orbitals. But how it will be possible all the time it will be same energy? Because whom it is going to join, whether it is a negative ions or neutral molecules, so depends upon the ligand. Now, the approach of the ligand towards that metal ion, naturally, the ions, that metal ions are receiving that lone pair of electrons from the ligand. So, naturally, energy will be fluctuating. So, as the energy it is fluctuating due to that ligands are having that spherical field or symmetrical field, the energy will be continuing. Degenerate orbitals, the energy will be continuing. Suppose the ligands are having higher energy than that of that free ion, there will be that fluctuation takes place. Maybe higher increasing energy or lower energy due to that, because d orbitals are also having what it is different orientation. So naturally there will be fluctuation will be taking place, increasing or decreasing energy will be taking place. Now we are going to see mainly 2 points to be noted. Orbitals lying in the same direction of the ligand. The second one, orbitals lying away from this approach of the ligand. Now what will happen here? Orbitals lying same direction of the ligand, so, like charges repel each other, so the potential energy will be increasing. Whereas orbitals lying away from the approach of the ligand. Now, what will happen? Here, lesser interaction takes place because away from the ligand, so lesser interaction takes place with the negative charge of the donor atoms. So, the energy will be lower than that of the donor atoms. Due to that, what will happen? Energy will be fluctuating, so that the splitting, the d orbitals will be split. So due to that electric field of the ligand, the energy of the 5d orbitals split up. So the conversion, which is called crystal field splitting energy. Hope you're clear with that. What do you mean by crystal field splitting energy? Now the main concept we have come. Orbital lying away from the approach of the ligand only splits up takes place. Now come to this point, the conversion of 5 degenerate orbitals. So 5 degenerate means it is having a equal energy, same energy for all the 5d orbitals. But the energy fluctuates takes place due to the approach of the ligand away from the orbital, right? So the conversion of 5 degenerate d orbitals of the metal ion into a different set of orbitals having different energy in the presence of electric field of the ligand. So that is called what it is? Crystal field splitting energy. Okay, now we are going to see octahedral complexes, tetrahedral complexes, how that energy takes place, all those ideas. Let us check it. Splitting of the 5d orbitals of free metal ion dxy, dyz, dzx, dx square minus y square and dz square. Okay, now let us go and check it how the splitting energy taken place. This will happen only in the free metal ion, right? So that is what the problem arises. So here 5d orbitals, that is dxy, yz, zx, dx square minus y square and z square of free metal ion, right? Okay, so the average energy taken place, it has to be equalized. Splitting also it has to be equalized, no? So average energy of the d orbital takes place. So average energy taken place, that point which is called barycenter, which is called barycenter. Okay, so barycenter is also known as center gravity of the rule. Okay, now again that splitting takes place. So here splitting energy, one will be lower, the other one will be higher. So lower energy, what are that? Higher energy, what are that? Let us check it. Okay, now here dxy, dyz, dzx. So this point, which is called lower energy. So lower energy also known as T2G. So this is actually what it is, lower energy. Lower energy. So lower energy, which is called what it is, T2G. The same way here what it is, dx square minus y square dz square. Okay, so here, so dx square minus y square and dz square, we call it as Eg. So Eg, it is actually what it is, higher energy. Higher energy. Okay, so now we are going to give that value. See here, out of 5 orbitals, 2 orbitals have gone away. So we can say 2 by 5 delta naught. Delta, here we are mentioning what it is, slight changes. Changes takes place, splitting up the energy, slight difference it has taken place. That's what we mention as a delta naught. So 2 by 5 or 0.4 out of 1, it is 0.4 delta naught. Okay, now 5 orbitals, here higher energy, no? So this is 3 out of 5 orbitals delta naught. Okay, now here 2 out of 5 orbitals, here 3 out of 5 orbitals, because it is a higher energy. And one more thing, here what it is, 0.6 delta naught also we can say. Hope you're clear with that, how that energy it is splitting. And now I just mentioned here lower energy of T2G and higher energy of Eg orbitals. So lower energy in which complex compound it will be possible means here dxy, dyz, dzx will be lower energy in octahedral complexes. Octahedral complex. And this is octahedral complexes dxy, dyz, dzx, and the same way higher energy dx square minus y square dz square. But just to the opposite in tetrahedral. Tetrahedral, this will be lower energy, dx square minus y square dz square will be lower energy, and dxy, dyz, dzx, that will be higher energy because of the orientation of the orbitals, 5d orbitals. Okay, now in our next class, we will talk about distribution of electrons of weak field ligand and strong field ligand. How it is distributing the electrons from D1 to D10. Okay, let us go and identify in the next class. Thanks for watching and please subscribe this channel. Hit the bell icon so that you will get all the notification. Thanks for watching.